Hey, welcome to Build on Chain. Here we have Ben Weinberg with Axelar. Ben, why don't you tell us a little bit about, your time at Axelar, how you got there, what you guys are working on?
Hey, yeah, thanks for having me. Been with Axelar for about 2 years, been in the industry for about 7 years now, based out of Toronto, Canada. Um, and how did I get to Axelar, you were asking? Met the team at a conference, fell in love with one of the talks a team member at the time had, and reached out to get more involved with them.
Um, yeah, why don't you tell us a little bit about what you guys are cooking up these days?
Yeah, let me actually share my screen here, just for the slides. If we can pull that up. Let's see. Can you see the slides? There we go.
Yeah.
Yeah, so I guess short answer to your question, a few different protocols that we're working on. The one that excites me most, I'm not going to get into too much today, is a protocol called the Amplifier Protocol, which allows you to basically connect all sorts of different chains in a much more fluid way. So we're talking like non-EVM chains in particular, the ability for chains to connect themselves. So we recently onboarded like Ripple, which is a chain that doesn't even have smart contracts on there. We onboarded Sui, Stellar, like non-EVM chains with our amplifier protocol. That's probably the most exciting stuff, at least in my opinion, that we've been working on. But before we get into there, I think we should get a bit more like what is Axelar, bit on general message passing, GMP for short, and our Interchain Token Service. And yeah, I can take it from there, I guess. So I guess the $1 million question is what is Axelar? What makes it unique? And if there's kind of one takeaway I think people should have from this, if there's nothing else you remember from this talk, is that Axelar is a blockchain that connects blockchains, enabling universal Web3 interoperability, which I admit is a little jargony and a lot to unpack. So I'll get right to it. But the two major improvements which Axelar offers in the interoperability landscape compared to like traditional interop services are in the form of scalability improvements and security improvements. Um, so let me break it down like this, the easiest way to probably visualize it. So Axelar is operating on a hub and spoke model. What does that mean? It means that every chain that you want to connect to another chain will do so by connecting to Axelar. And you can kind of visualize it like this. And what's interesting about it is that you can look here of all the different types of chains that connect to Axelar. So you have like chains from like the EVM ecosystem, like Ethereum, Polygon, Avalanche. We also have chains from the Cosmos ecosystem, like Osmosis, the Cosmos Hub, Region, Injective. This chart precaution is out of date. We currently connect a lot more chains in this. I think we're at over 80 chains now, as well as from like the non-EVM landscape, like I was mentioning before. And the major improvement which we have by going with the hub and spoke model is in terms of the way we scale. So in sometimes the way it worked in the interoperability space was you would have these things called pairwise bridges. And you can look at it like in this slide. Imagine we have three blockchains like Ethereum, Binance, and Polygon. If you wanted to connect each of those chains to each other, these three chains would require 6 bridges to connect any chain to any chain. If we want to add just one more chain, like Avalanche, those 4 chains would now require 9 bridges. And then we envision a world where there's going to be someday 1,000 chains connected or 100,000 chains connected. We're really looking in the long-term future. So the number of bridges that you'd need to actually connect any chain to any chain simply wouldn't work. Rather, what would work is more of a hub and spoke model, what we have now, where all what you need to do is plug in your chain to Axelar, and right out of the box, you're connected to every other chain that is connected to Axelar. And we see this as a limitation with certain interop providers where like, you may say like, yeah, we connect like 50 chains, but if you want to go to Binance, you can't go from Ethereum. Or if you want to go to Polygon, you can't go from Avalanche. Whereas with Axelar, as soon as you plug in, you can immediately connect to every single chain that is connected to Axelar. So that is
Okay.
how we get to like the major scalability improvements in the interop space compared to like how the industry's done it traditionally. The other major improvement is in terms of security. So if we go back to this line up top here, is that Axelar is a blockchain that connects blockchains. So if we look here, this hub, Axelar in the middle here, is itself a layer 1 blockchain. It's built the Cosmos SDK. There's currently 75 validators, permissionless validators, might add, that are kind of securing the entire chain. They're adding blocks like you do with any other layer 1. Let me pull up our little a slide I have with some of the validators that I cherry picked from here. Anyone who's familiar with the Cosmos ecosystem might be familiar with some of these validators, like Informal Systems, Focachu, Figment. These are validators who are securing many other Cosmos chains in the ecosystem. But what's really exciting is that we don't select the validators per se. Like if you accumulate enough stake of our AXL token, then you can also be one of the validators for the Axelar chain. We don't really cherry pick who's coming in and out of our validators. It's completely permissionless. And what's nice here is that we're all in this ecosystem. In the interest, in the beginning, what brought us in was like blockchain technology, the idea of a decentralized secure network that was powering Bitcoin. So it makes sense that what should be powering the interop layer, connecting different blockchains, should itself be a blockchain as well. So that's how it comes from we really benefit from like the security side of things. And like, you don't need me to, most people will probably know of like the shortcomings which our industry has had, especially when it comes to the interop layer with like centralized bridges, like a 2 of 4 multi-sig, like we've had with some major hacks occurring in the ecosystem. And don't just take my word for Axelar being a really security first approach for interop. This is a bridge report done by Uniswap. I left the QR code if anyone wants to check it out. And basically what Uniswap did was they did like a deep dive into the whole interop landscape and went through one by one of all the different interop players. And Axelar was one of 2 teams that got like the thumbs up from this report. So it's a really, really good read if anyone wants to like kind of check out the landscape of the security side of the interop space.
For sure.
So that brings us back to where we started. Axelar is a blockchain that connects blockchains. Talked about that, enabling universal Web3 interoperability, not just limited to EVM, not just limited to Cosmos, really any different type of chain that wants to connect each other can be connected with Axelar. So what can we actually do now that we have this ecosystem? There's of course the ability to send assets, but what really excites me is this service called General Message Passing. Let me pull that up. General Message Passing, as the name suggests, allows you to send messages between 2 chains. You can go from any chain and send something as simple as like a little string like WAGME, or you can send something a little bit more robust like a function signature to actually trigger functionality on different chains. And we see this in the wild in many different places. Some people might be familiar with like Squid, which is basically a service which allows you to swap tokens between different chains in one click. So you can see like in this screenshot, when going from like holding the Graphs token on Ethereum to receiving USDC on Optimism all in one click. And Squid leverages GMP to actually do this. It interacts between dexes on different chains to actually swap these tokens. And for the user, it's just the one-click experience. But behind the scenes, Squid is actually making a bunch of swaps with these dexes, all powered through GMP, through General Message Passing.
Got it.
I'm going to actually share my screen now to get a bit deeper for how this works. Let's see. Any questions so far on anything I talked about?
No, not right now. This makes sense to me. Yeah. Yeah, it's cool to see like a fully on-chain solution to like interoperability. It's pretty unique.
Yeah. One thing I actually wanted to touch on as well is I may have noticed I skipped from the slides there for validator-based security. Remember how I was saying that Axelar is itself a layer 1 with the 75 validators. So how do we get that kind of security? Well, these validators that we are running, or that are running on our chain, I should say, they're doing, of course, the traditional layer 1 validator functionality, but they're also running nodes on all the different chains that we integrate with. So what does that mean? It means that when you are sending a message, for example, if I click on this message right here, which is like a cross-chain transaction that was sent from Ethereum, Not really sure what it's doing, but the point is that this transaction, you can actually see all of the different validators coming to consensus, basically saying like, hey, are we all aligned that this message was sent from Ethereum and is going to X destination chain? And you can see 94% of the validators here came to consensus. And that is kind of the backbone of Axelar security of cross-chain messaging security, is actually having all these individual validators coming to pretty unanimous consensus about the message that was sent. This is all visible here on our Axelar Scan Block Explorer. We'll be seeing a bit more of that in a second, but I think that's a pretty important point to call out. So jumping back, yeah.
Quick question. So for the validators, like, is I imagine there's like a staking system and like a slashing system, obviously, for
just like any layer one on Cosmos, you can like delegate
cool.
to the validators. Yeah.
Okay. And then is there kind of like an uptime expectation for this? And I think also you mentioned that like validator sets are based on basically how much stake you have, right?
Mm-hmm.
Okay.
Yeah.
Cool.
Become a valid. Yeah. Anyone could be a validator if you accumulate enough AXL to be one of the top stakers. Yeah.
Super cool. Okay.
Cool. So I'm gonna pop open Remix. Is this big enough?
Yeah, I think so.
Yeah, we have some starter code here just for time's sake. I'm not gonna go through everything. I just want to focus on the two most important components of sending a GMP message. So this can be thought of like as a little hello world application for sending a GMP message. I'm actually gonna close this one. So what's going on here? We have a few storage variables, an event, and where we can start looking is really in the constructor. Notice we pass two arguments in, a gateway and a gas service. Now, these are the two kind of critical tools that you'll need to use, or developers will need to use to actually send a GMP message. A gateway is, as the name suggests, like can be thought of as literally a gateway contract for interacting with Axelar. There's a lot of that's going on with the gateway contract beyond the scope of sending a GMP message. But for the purpose of this demo, the gateway is what we're going to use to actually trigger a function that will fire off the GMP message. The gas service is an interesting one. This is another contract that also lives. Both these contracts live on every chain that is connected to Axelar, with the exception of the Cosmos chains that are using IBC. And what the gas service does is it basically abstracts the difficulty of paying, of needing multiple tokens to conduct a cross-chain transaction. So what does that mean? Let's say I'm sending a transaction from Ethereum to Avalanche, and it's going through Axelar for the security layer. Well, what does that mean if you think about it? That means we need 3 tokens, right? I need Ether for the source chain, AXL for the Axelar layer, and then AVAX for the destination chain on Avalanche. Right. And that's kind of a pain if you need to go through that every time. So what the gas service does is it enables you to basically pay for the entirety of the transaction in the token of the source chain. So you only need to send Ether to this gas service, and then all the other gas payments are taken care of. It's still coming out of the sender's pocket, but they don't have to worry about now like manually sending AVAX on the destination chain and AXL on the Axelar chain. It's kind of all abstracted away from you.
Got it.
So that's the purpose of the gas service. And you can see here in the constructor, we basically pass in these 2 arguments, one to the executable contract and one to our gas service, storage right here. Executable is kind of a helper contract which we inherit from here up top. It basically gives us access to this execute method, which I'll get to momentarily. So the next thing we want to look at is this set remote value function. It's pretty straightforward. It takes 3 parameters, like the name of the destination chain that we're sending a message to, the destination address that we're sending to on the destination chain, and then like just the vanilla GMP message that we're sending. So remember before, like in the slides, I had like this WAGMI, for example. So this string would be passed in here for the 3rd parameter. It's also marked as payable because we're going to be sending a message value to pay for the gas with the gas service that we talked about up here in the constructor. So what do? We first have a required statement saying like, hey, make sure you send non-zero value, otherwise revert because you haven't sent any gas for the gas service. Then we're going to encode our message from a string to a bytes type, because that is the type that the Axelar needs to actually send the message. Now we get to the kind of cooler part. We're actually going to use our gas service and our gateway. Our gas service has a function called, it's a bit of a mouthful, but it's aptly named pay native gas, pay native gas for contract call. Okay, and that is going to do exactly what I said before. It's going to allow for Ether or whatever the native token of your source chain is to pay for the transaction. So let me actually pull up the function signature here directly in Remix, because I don't remember all the parameters that we need. Pay native gas for contract call. It needs a sender, a destination chain, destination address, a payload, and a refund address.
Got it.
So the sender will be this contract, address this. The destination chain will be the parameter from line 28. Destination chain, next will be destination address. The next will be the payload, not the message, because remember we have to pass it in as a bytes type. And then finally, the refund address will just be the message sender. What does that mean? It means that whoever sent this transaction, if you, for whatever reason, spent like way too much funds, you sent like 1 Ether or whatever, then the surplus that was actually sent to the gas service will be refunded back to whichever address I specify here, which in our case, we just want to be the message sender. So at this point, when we actually trigger the transaction, we will, look at this, smart enough to know what I'm doing. It will pay for the transaction on the Axelar gas service. Now we actually just need to use the gateway to trigger this call contract function. Yeah, so found it right here. So the issue is that in the Axelar executable function, I forgot that gateway is registered as a getter function. So we just need these two parameters like this. Sweet. And now we can actually call contract with similar parameters from the pay native gas for contract call function. And once we trigger this function, we will actually have sent a message out of the source chain to Axelar to eventually get forwarded to the destination chain. But we're not done yet because I don't have the slide here that I wanted. But what actually happens when we arrive at the destination chain? Something needs to get executed, which is why we have this bottom function here of execute. And I'm not going to write this one up. We'll just use the logic that was built into here, or that I left here from before. But you can see this function is getting overridden here from the Axelar executable, which we inherited from up top. It takes 4 parameters, including the command ID. Don't really worry about what that is for now. I'm actually just going to remove it. It's basically like a universal identifier across Axelar transactions for all chains. But that goes beyond the scope of this. But we do get our source chain. So where is the transaction coming from? The source address, who's sending it on the source chain, and the payload, which will be the message that we sent. So what we want to do is actually decode this payload to a type string right here. So we get a matching type that was sent in back on the source chain here on line 28. We then can just save our source chain and source address to our storage variables here and emit an event saying like, hey, this successfully executed with the GMP message that was sent. So I'm going to deploy this. Yeah.
So super quick, this is on the, like what you're showing now, this is on the source chain still, or this is on the destination chain?
Well, so yeah, you're going to see right now. So in this case, I'm going to use this contract. I'm going to deploy it on 2 chains. In fact, I'm not going to deploy it. I've deployed it before, so it'll save me the time for us waiting for deploying it. But I deployed this exact same contract on Binance and on Avalanche. You know, no, I will deploy it. Let's do it right. So we need in our constructor, pull this up. We need in our constructor the 2 contracts, our gateway and our gas service. So I can find the address for both of those contracts in our docs. So for Avalanche, we have this address. Let me throw that in right here. And for the gas service, we have this guy. I'm going to transact. You know, let me make sure I'm on the right network here. Yeah, I'm on Avalanche. Transact again, confirm. And I'm going to delete these guys and add this here. So this is our Avalanche instance of this contract. So yeah, so this goes on both source and destination. In this example, of course, in more robust examples, we can have like 2 different contracts being deployed, but for simplicity, we'll have like the same contract deployed twice. And now on Binance, we have a different gateway address. We have the same gas service. Oh, I forgot to change my address, or my network, I should say. So let me go to Binance, testnet. Hopefully I have money. There should be enough. Transact. Cool. Now we have this contract deployed twice on both those chains. And let's actually use it now. I'm going to go back to Avalanche to send a message. So let me pull in this address. And now let's interact with the set remote value function. So all I have to do is specify Binance as the destination chain. Destination address will be this instance that we just deployed. And the message is going to be like, hey, from Avalanche. And this should be received on Binance. Now this is going to revert. Why? Because remember this require statement. We need to send some gas.
Right.
So let me add that right up here. So this should be enough. Transaction now goes through. And in a second, we will see our transaction hash pop up here in Remix. I can take the hash here and go right back into Axelar Scan. Pull up here, testnet axelarscan.io. And all I have to do is, actually before I throw in the transaction hash, let me brief detour. On Axelar Scan, this is our block explorer. Since we are layer 1, we do have a block explorer just like every other layer 1. You can see some fun facts or stats about here with Axelar. This table might look familiar, like from the slides. It's more early version that we have. This is the more up-to-date one of all the chains we're currently connecting. You can see like some of our recent connections with Amplifier, like Sui, Ripple is here somewhere. Ripple EVM was a pretty exciting one because we're the canonical bridge between Ripple and its sidechain, its EVM sidechain.
Amazing.
But I digress. Let me throw back that transaction hash here. You can see it's insufficient fee paid. I can actually, from the Explorer, manually add the gas myself.
Oh, that's super cool. All right.
Yeah, we also have a JavaScript SDK for like, like more front end, more robust applications where you can add the gas programmatically.
Nice.
And notice how all I had to do was pay in the message value of Avalanche. I don't need to actually spend any Binance or any AXL. Like the gas service is abstracting all that away from us, which is pretty
Yeah. Huge UI improvement, UX improvement.
I will spare you the details of this for now, but what we can see here at the bottom is the step-by-step of the transaction. So currently, we have sent the transaction, we have paid for the transaction, this and this happened on the Avalanche chain. I can actually see, if I zoom in a bit, the Avalanche Explorer logo, Snowtrace, I think it's called. I can click on this transaction hash, takes me right to Snowtrace, so I don't have to trust what I'm seeing just in the Axelar Scan Explorer. It takes me right to the native Explorer of any given chain as well from the Axelar Scan Explorer. At this point, we've seen that the transaction confirmation come through. Notice this is an Axelar Scan logo because this transaction hash is now happening on Axelar. I can even see the polling of our validators coming to consensus about the message that I sent. You'll notice there's going to be, once this shows up, there's going to be less validators here just because, and the consensus is less just because this is testnet. And momentarily, we're going to see the final 2 legs of the transaction go through on Binance. So at this point, this approval is basically going to be like, hey, the validators on Axelar have approved this message, and we are letting the gateway know on Binance that this message is approved. Why is this necessary? Because when we actually go for the execution of this transaction, this execute corresponds to what we wrote up here. That's always going to happen. But remember, we overrode this transaction from a contract, Axelar executable. So what's actually going on here in the base layer? Notice there's this validate contract call function. What this is doing is we'll basically check if that approval step 4 here, has successfully executed. If it hasn't, it's going to revert, and it's going to be like, hey, like what's getting executed here is not authentic data. Like this is not what the Axelar validators have signed off on. If
Okay.
on the other hand, the transaction has been marked as approved, which it has now, then this if statement will pass. And then that'll allow us to actually execute this, albeit simple, logic on our destination chains here. So it's going to decode the payload, emit this event, and save these two variables in storage, which it should do any second. Yeah, any questions about what we're seeing here on the Explorer?
Yeah, so I guess like let's say I make a call. We'll use these two chains as an example. I make a call from Avalanche and I expect something to happen on BNB. But my like whatever that call is would have failed on BNB. Not because of any of the because of the bridge, but because I gave it the wrong data or so what have you. So
Yeah,
what does that
something
look
here is
like?
reverting. Yeah.
Yeah. Well, like what does that case look like?
Then the transaction is averted, right? In the end of the day, think of GMP, it's just two separate contracts. It's no different than if you had two contracts on Avalanche in this case,
Mhm.
and you send a call to another contract on Avalanche and it reverts. In the end of the day, your transaction on the source contract executed and the receiving contract, whether it's on a different chain or on the same chain, has reverted. So yeah, what will have already taken place on the source chain will have executed. I'm not sure it's taking so long this time. It's not normally this long, but I guess Murphy's
So
law live coding.
like those two are those two ideas are atomic. What happens on the source chain and what happens on the destination chain?
Exactly. So like this you
Awesome.
can see, right? This is already executed on Avalanche. It's
Mhm.
done. Like there's nothing that we can go and undo here because it's already executed. Looks like we've executed here. Yeah, there we go. So we can actually see the transaction getting executed. I can click into it right here. Takes me right to the Binance transaction. I can see my executed event being emitted with my hey from Avalanche message. I won't do it for time's sake, but if I were to pull in this contract and actually query the message variable, it's empty here because I'm on Avalanche. But if I
Mhm.
switch my MetaMask to Binance, I'll see that hey from Avalanche message now being stored as it's supposed to line 51. But we can confirm that it worked because we see the event here being emitted on Binance.
Got
So
it.
that's like a simple hello world example. There's a lot more that we can do with a GMP. I'll share one quick one here from my actual editor. This should look fairly familiar, and particularly these lines right here. So in this case, what we're doing, this, by the way, this Axelar examples repo, I'll share a QR code in a minute, has like a whole well of examples that you can check out for like all the cool stuff you could do with Axelar GMP. In this example, what we're doing here, we have an NFT, a very simple one, just inheriting from OpenZeppelin 721 standard. We then use this Axelar contract that I wrote up to actually pass a message, an encoded message with the signature for the safe mint function to actually
Mhm.
mint an NFT on a destination chain. So if we start from the constructor again, same thing as before. We pass in the address of our gateway. Let me make this a bit bigger. We pass in the address of our gateway. We pass in the address of our gas service. In this case, we're also passing the address of our NFT contract. But don't worry about that for now. The main thing that we need to take away is that the gateway and the gas service need to always be recognized. Then if we go to the mint NFT on destination chain, it's fairly similar to the last example we have, right? We pass in similar parameters like where are we going, which chain, which address on the chain, make sure that we are sending a non-zero value for gas. In this case, we're running ABI encode with signature instead of ABI encode because we're actually passing the entire function signature of the safe mint function, which we defined here on our NFT to actually be mintable. So we pass in the two address, the two parameters which it expects. We also pass in the value for these parameters that we expect. So like the receiving address is the first parameter here, and the ID of the NFT being minted, the token ID, is the UN256, which it expects. So we can pass in this case, not just a hey from Avalanche message, but an entire function signature to be generically executed on the destination chain. How do we send the GMP message? Same as before. We talk to the gas service. We call the pay native gas for contract call function, exactly like we did here in our previous hello world example. Similar parameters being passed in. The only difference is the payload, the actual GMP message. And then we send it away. On the execute function, all we now have to do is a generic Solidity call with the encoded signature that we passed in. And if we actually run that, I ran it before here, you can actually see our NFT balance on Phantom. The destination chain in this case was 0. When I ran it again, it was 1. The script being run is this here. So you can see we're querying the balance of function on the NFT twice. Once before and once after we run it. This entire examples repo is using a hard hat local environment. So it's not actually running on chain. It's kind of just simulating it. But it's just meant to be kind of food for thought on what can be done with GMP. Any questions on this?
No, not as of now.
Awesome. Yeah.
I had a couple more questions about like how the Axelar chain worked and like yeah, forgive me if these are stupid questions.
No, go ahead.
Like, so I guess, you know, we have what I think you said 75 validators. What I guess, like, is there like a certain number of them that need to approve before something goes through? Like, what determines latency on this? Obviously, this is a test net, so I'm not like, you know, holding you to the latency of your test net, of course. But I'm just kind of curious.
You mean like the threshold for a transaction to go through?
Yeah.
Yeah, so the exact number I actually don't have off the top of my head, but if we look through past transactions like on mainnet, I think I must have closed it before, but it's typically we're looking like in the 90% threshold for a transaction to go through. I'm not going to say that's the minimum required, but that's what you will typically see.
So yeah, I asked the question earlier about like uptime, I guess. So that's like the thing that I was thinking is like, you know, if the validators, like you determine who is a validator by what they have staked, but I guess what forces validators to like be online and let things go through, you know, because that's
yeah, if like we kind of monitor that ourselves, like if validators are not doing what they're supposed to do, then we have communication channels with them that we can reach out to them. But yeah, we kind of monitor to make sure that the validators are let me actually go to our mainnet one, but that the validators are behaving the way it's supposed to. And we can actually see it right here. So like the uptime that some of our validators are having.
Super cool.
You can see the chains that they're all supporting. And if we see that some of our top validators are not, you know, have low uptime, then we'll just reach out to them.
Oh, so the validators are chain specific?
So they're like, validators for the Axelar chain, but they're running nodes on all these other chains. You can see.
Got it. Yeah. Do they have to? You know, if I'm a validator, but you know, I don't really want to support Phantom, do I have to do that, or the expectations that everyone's on all of them?
Yeah, we expect them to. Like,
okay.
Like, there's no, I don't think, actual technical requirement. Like, if, for example, Figment were to stop supporting Arbitrum, they would be removed because it is based on stake. But it's something that we expect from them.
Okay. Cool.
Yeah. I guess this kind of this last demo I had kind of segues into the last point I wanted to make with Interchain Token Service. Something we released about over a year ago now, and it's kind of doing what I demoed here, albeit in a much more robust way with ERC20s. All what it's doing under the hood is basically it's a contract that lives on the different chains that we're connected to, and it's sending cross-chain GMP messages to like mint ERC20s and subsequently burn on the source chain and mint on the destination chain when you want to move an asset between two. So what I'm saying that ITS is just another example, just like this, sending mint messages via GMP to an ERC20 on the destination chain and subsequently burning on the source chain to actually move an asset between two chains. Now with ITS, there are a lot of ways you can integrate your token. It's meant to be like a very flexible baseline service. You can integrate custom tokens like stable coins there. You can also deploy tokens fresh from ITS itself. So we have this portal here, which is meant to be like a kind of no-code solution to integrate with ITS. You can also go in programmatically to have like the most flexibility for integrating with ITS. But you can actually also just go through the portal. So for example, if I want to deploy a token onto Avalanche, I can connect my, oh, connection decline. Let me refresh this here. What's going on here? Oh, confirm. That's why. Yeah, I can just fill out this form to actually deploy a new token. So I can call it test token TT. Is it mintable? Do I want others to be able to mint this token, or do I want to just have this total supply and no tokens will ever be minted? I'm going to go with this because I'm not going to go through the whole deployment mechanism. We can see all the different chains I can deploy with in one click. I'm going to deploy Binance, Ethereum, Bearchain, as many or as few as I want. And then once I click deploy, I'm going to not do that now for time's sake. It'll actually deploy that token on all these different chains. I already deployed a token just before this call to show you what it looks like once it's done. You can also see it on Axelar scan. Here I deployed this demo token from Avalanche to Ethereum, 2.5 minutes. And here's what it looks like on the portal once it's deployed. You'll see I minted 12,345, 1, 2, 3, 4, 5 tokens. You can see the symbol, all the different information about my token. You can see there's no balance on Ethereum, but I can actually transfer the token from Avalanche to Ethereum from the portal. There also is the ability to add ITS tokens onto Squid. Remember, Squid is this service that I was showing before, where your token will be listed alongside like any of the other tokens that are listed there to actually make it bridgeable between chains. And yeah, I could do a whole separate talk just on ITS, but that is it in its simplest form, the ability to either deploy fresh new ERC20s or simply paste in the address for a token and integrate a more custom token via the portal and make it bridgeable between different chains. And yeah.
Can you, so let's say I have like a custom token, I made Nishad USD, right? And
Sure.
I have this on Ethereum. And I would like to have this on, Avalanche, BSC, and Ripple, let's say. So I would just pull that up. I would put the address in there, and then basically with a no-code solution, I can deploy these to these chains.
So what you can do,
Go ahead.
so you can register your token as a canonical token. So let's say you have your stablecoin on Avalanche. You can register that token here, and it would be basically using a manager. So there's with ITS, when you integrate your token, you have something called a token manager, and that's kind of like the thing was like the buddy for your token, which handles it basically facilitates the relationship between your token and ITS, doing a number of things that I won't get into now. But the main takeaway is that there's a number of different type of managers. The main two being lock and unlock or mint and burn. So going back to your question, if I were to have like a USD token and I want to integrate it here via the portal, I paste in my address, 0x my address. Then the token manager type that will be registered will be lock unlock. So let's say on Avalanche, you have a lock unlock token. Then what you would do here is deploy what's called interchain tokens, which are like these Axelar based like kind of wrapped tokens
Right.
across all these different chains. So it wouldn't be your custom stablecoin on all the other chains. It would just be your custom stablecoin will be the canonical token on Avalanche that was registered here, which will be locked unlocked. You can only have a lock unlock on one chain. The rest will be mint burn. If you want to now have your custom token integrated on all chains rather than just on a single chain with the kind of wrapped tokens on the other chains, then that you would do programmatically.
Okay.
It's really as flexible as you want it to be.
Super cool. All right. Okay. Yeah, that was all right, Ben. Yeah, thank you for that demo. That was super cool. I guess like, what kind of projects do you see being built on top of ITS and like, or even, I mean, GMP, like, what do you expect to see built from there? What does Axelar expect to see built there?
Yeah, so I'll start with the first one with ITS. The thing that excites me personally most is anything like stablecoin related. It's such an interesting fit for our industry. But we've seen everything and anything being built on there. Seen like a lot of meme coins being built on there as well. Game assets being used there. So really anything like, and in my opinion, like I want to move into a world where like we don't really have the conversation of which chain are you deploying on. In my opinion, it's not really a question of what's being built on Axelar, it's what's being built in our industry. Because if you're building in Web3, you should be on as many chains as possible, in my opinion.
Right.
So you should be building with a cross-chain service like Axelar from the get-go. So it's not like what are you excited to see built on Axelar? What are you excited to see built in crypto in general? That's kind of how I look. So yeah, stablecoins is such an exciting topic, I think, for everyone, even outside of the interop space. And then with GMP, same thing applies. Like any sort of application that can be built in Web3 can, in theory, be built with GMP, because all it is composability between contracts, right? That's what Ethereum kind of pioneered back in the day. And we're kind of just taking that step forward for not just one chain, but for all the different chains.
Awesome. Yeah, it makes sense. It's like there's a time a long time ago when you have to kind of like make a decision. This is my chain. This is where I'm going to live. But in this kind of like increasingly interoperable world, and because of like providers like you guys, it's
and the infra provider is one step, but like that's why I wanted to show off the portal, because like you have to make it easy as well. Like I can sit here and preach security and like the 75 validators and like why Axelar is like the most secure way to conduct interop, but if it's too difficult to do so or too difficult to understand, then that's
no one's
also
going to do
something
it.
on us. It's also something on us to solve. That's why I really wanted to show the portal for today, and then excited to show off like other tools that we also have in the pipeline.
No, I really appreciate that, and it's really like it's a philosophy that I think is not popular enough within crypto, like making stuff usable. So it's like me. I really like personally really like that, and I'm happy to see you guys doing it. So
Yeah,
thank you.
awesome.
I think that's all we got. Thank you, Ben, for coming to Build Onchain. Hope this was cool for you. Really informative, and I'm sure our users or our viewers will really love it. The resources that you talked about will be put in the description. And yeah, thanks again.
Thanks for having me. It was fun.